Okay, so this is a video for today, for the slides for today, 9:15. So in class, we did go over the defining what an arithmetic sequence is and a geometric sequence is. Remember, an arithmetic sequence is when you're adding or subtracting that same number. That's an arithmetic sequence. We did this in class, so you should have this finished. Um, we went over this slide. So if you change it to, instead of adding -2, you change it to adding 4, how would the pattern change? Well, then it would be increasing instead of like decreasing. On this one, it will still be an arithmetic sequence because it's your common difference. It's a constant. It's still 4. You're just adding 4, adding 4, adding 4. So as long as that happening, it should remain in arithmetic sequence. If possible, write the first 5 terms of the new sequence. Okay, so if we start with 11, we're going to add 4 to it. So 11 plus 4 gives you 15. And then 15 plus 4 is 19. 19 plus 4 is 23. And 23 plus 4 is 27. Okay, on this one, where it's asking you to list the sequence that are arithmetic, you need to look at the slides from yesterday, or you can look on your book in page 109 and page 111. Okay, on page 109 and page 111, you have this sequences. Okay, these are the sequence they're talking about, like put them in order. So, or put them by what type of sequence they are. So arithmetic. Okay, so A is not arithmetic because even though you're adding like 45 plus 90 plus 180 plus plus 360, this is not an arithmetic sequence because we're not adding the same amount. Okay, B is an arithmetic sequence because we're adding 2. So -4 plus 2 is -2, plus 2 is 0, plus 2 is 2. C is not arithmetic because we are multiplying by 3. -2 times 3 is -6. -6 times 3 is -18. -18 times 3 is -54. D, we adding 3 plus 5 plus 7. Okay, even though we're adding, we're not adding the same amount, so it's not an arithmetic sequence. Okay, E, we are subtracting -9/4. Every time it's subtracting -9/4 or adding -9/4. So when you do that, you are adding the same amount all the time, even if it's negative. So E is an arithmetic sequence. Okay, F, we are not subtracting. Okay, so it's not arithmetic sequence. G, it's going from positive to negative to positive, negative. It's a nice sequence, but it's not arithmetic. H, okay, H, it looks like we're adding 4. So -20 plus 4 is -16, plus 4 is -12, plus 4 is -8. Since we're adding the same amount, H is an arithmetic sequence. Let's take a look at the next one, page 111. I, from -1 to 2, you add 3, and then you add 5, and then you add 7. Okay, again, we are adding, but we're not adding the same number, so it's not an arithmetic sequence. J, I believe you're multiplying by 1/2. That's why the only number on the top, on the bottom is changing. The top is multiplying by 1, and the bottom you're multiplying by 2. So it's not arithmetic. K, it is in the arithmetic sequence. You're subtracting, you're adding -1.5. So 6.5 plus -1.5 gives you 5, plus -1.5 is 3.5, plus -3.5, it should be 2. Okay. L, you subtract 1, subtract 2, subtract 3, subtract 4. So even though you're subtracting, you're not subtracting the same number, so it's not going to be an arithmetic sequence. Okay, M, it doesn't look like it's an arithmetic sequence. You're not subtracting the same amount. It does look like a geometric sequence. A geometric sequence is the one that you are multiplying. Okay, on this one, it is an arithmetic sequence. If you get the second term and subtract the first term, you'll notice that it gives you 20.5, and every time it's 20.5. So that is your common difference, -20.5. So this one, it is an arithmetic sequence. O, it's square root of 5, square root of 4, square root of 3, square root of 2. It's a nice pattern, but it's not in the arithmetic sequence. Now, if it was just, 5, 4, 3, 2, 1, that is in the arithmetic sequence because you're just subtracting 1. P, -4, and then 12, and then -36, and -108. That does not look like an arithmetic sequence, especially when you're going from negative to positive to negative to positive. You're not going to be adding or subtracting the same number. Okay. So that's what you're going to do for this one. Okay. For A, you're going to look all the arithmetic sequences and then tell me what the common difference is. So like I was starting right here, B is the D was equal to 2. That means we're adding 2 every time. E, we're subtracting negative, or we're adding -9/4. That's C. So B, we're adding 2. E, we're adding -9/4. The next one was H. We're adding 4. So D would be, H would be D equals 4 for your common difference. Let's see. The other one was K. Our common difference is -1.5. And the common difference would be -20.5. And again, if you're not sure like how I'm getting those numbers, you just get the second number and then minus the first number, and that should give you, it could give you either a positive number or it can give you a negative number. Okay. And then O and P were neither of those. Okay. Let's see, for slide number 9, now we're dealing with the geometric sequence. So a geometric sequence is when you're multiplying, or you can say dividing by the same number, and that number is called a common ratio. Okay, so notice here we are multiplying by 2. Okay, so the common ratio is equal to 2. So we can just use the letter R for our common ratio. Okay, number 11, how will the pattern change? So instead of multiplying by 2, we multiply by 3. Well, it's going to increase a lot faster. So it's going to increase quicker, because now we're multiplying by 3 instead of by 2. So instead of 1, 2, 4, 8, it would be 1, 3, 9, 27. So notice how the numbers are getting bigger faster. Okay, the sequence still geometric? It is geometric, because we're still multiplying by a constant number. We're just multiplying by 3. It's not changing. So it is still a geometric sequence. Write the first 5 terms. So the first 5 terms, the first term is 1, and then 3, and then 9, and then 27, and then 81. How will the pattern change if we multiply by 1/3? So I don't know if you ever noticed, but when you multiply by a fraction that is less than between 0 and 1, your numbers are actually getting smaller. Okay, so the pattern, the number would actually be getting smaller. They will never get to the negative part, but they will get very, very, very close to 0. Is the sequence still geometric? Yes, it's still geometric. We're multiplying by 1/3, and it's not changing it to a different number. It's just by 1/3. Write the first 6 terms of the sequence. Well, the first number is 1, and then 1 times 1/3 would be 1/3, and then 1/3 times 1/3 would be 1/9, and 1/9 times 1/3 would be 1/27, and 1/27 times 1/3 would be 1/81. And I don't know if the sixth one would be 181 times 1/3 would be 1/243. Okay, check your calculator. All we're doing is just multiplying the bottom by 3. The top one is going to stay the same because we're multiplying by 1. Okay, so how will the pattern change if we multiply by -2? Well, if you multiply by -2, it's going to be going back and forth. So you start at +1, and then goes to -2, and then it goes back to +4, and then go back to -8. So it's going to be switching between positive and negative. It's also called alternating. And there's another word. I'll see if I can remember what the word is that means the same thing, changing from positive to negative. Okay, suppose the sequence has the same starting. Okay, is it still geometric? It is still geometric because we are multiplying by a common ratio. that is -2. So as long as you're multiplying by the same number all the time, it's still going to remain a geometric sequence. So it's still a geometric sequence. We're still multiplying by a common ratio. So write the first 6 terms of the new sequence. So we start with 1, and then 1 times -2 is -2. -2 times -2 is +4. 4 times -2 is -8. -8 times -2 would be +16. And then +16, -32. So just back and forward, positive, negative, as you're multiplying by that -2. When you multiply negative times a negative, that gives you that positive. Okay, consider the sequence 270, 90, 30, and 10. So notice how it's going down. And so Devon says that he can determine each term of this sequence by multiplying each term by 1/3. So the common ratio is 1/3. Chase says that he can determine each term of this sequence by dividing each term by 3. So the common ratio is 3. So who is correct? Okay, so even though they both get the same answer, Devon is naming it correctly. The common ratio is 1/3, not 3. If you were multiplying by 3, okay, if your common ratio was 3, then it would be 270 times 3, which is 810. Okay, so it wouldn't be going down, it would be going up. Okay, consider the sequence you cut out in the getting started list, the sequence that are geometric. Okay, so now we go back to the cards. And again, don't cut them because you're gonna lose them. Okay, so keep them like this, and then it's just easier to take a picture of it and email it to me. So A, is A geometric? Yes, it is. You're multiplying by 2. 45 times 2 is 90. 90 times 2 is 180. 180 times 2 is 360. We did B already, was arithmetic. C, we're multiplying by 3. So that one is also geometric. D is like a neither. It's not arithmetic or geometric. E, we already did, it was arithmetic. F, we are dividing by 10, or we're multiplying by 1/10. So the correct way would be R equals 1/10. We're multiplying by 1/10. Okay, G, neither. H, arithmetic. I, neither. J is geometric. We're multiplying by 1/2. So R would be 1/2. K, we say arithmetic. L is neither. M is also a geometric. We're multiplying by -1/4. And that's how you change it from negative to positive to negative to positive to negative to positive. Okay. N is arithmetic. O is neither. And P is also geometric. We are multiplying by -3. That's how we get that negative, positive, negative, positive. Okay. And I think I answered the next question also. Consider the squares that are neither arithmetic nor geometric. List the sequence. Explain why these sequences are neither arithmetic nor geometric. So you can say the ones that are neither, you're adding, but not by the same term. So not by the constant term. Or if you're multiplying, I don't think there was one where we multiply by a different number. It was just like an arithmetic one. Or the other one just didn't have a, there was no pattern where you added. It was just a nice sequence. Okay, consider the first 2 terms of the sequence 3, 6. So Dante says, this is how I wrote the sequence for the given terms, 3, 6, 9, 12. Kara, this is the sequence I wrote, 3, 6, 12, 24. Who is correct? Both of them are correct. You just have to tell me which one is you agree with and why you agree with them. Okay, so there's no wrong answer. And 24, consider the sequence 2, 2, 2. Identify the type of sequence it is and describe the pattern. So this one, again, there's no wrong answer. If you say it's arithmetic because you're just adding 0 to it every time. Or if it's geometric because you're multiplying by 1 all the time. So there's no right or wrong answer. Okay, so hopefully this helps you. If you have any questions, just send me an email. I can probably reply it after 8 o'clock just because I got practice. But yeah,